Okay, so the previous class we have discussed about LCR components, LCR circuits. So one acts as a low pass filter and another acts as a high pass filter. Okay, so we'll go into further details of that. LR circuit as a function of frequency. What is this? I call it as current. So all low frequency currents for frequency 0, XL is 0, and as frequency rises, this opposition also rises. So the current reduces with the rise in frequency. Okay, and for CR circuit, for frequency 0, X is infinity, 1 by j omega c. J omega. And as frequency rises, opposition reduces. So current versus frequency graph at loss and deniki. Okay. And if I join these two in series, రెండింటిని series లో connect చేస్తే ఏం జరుగుతుంది? So here I am taking LCR in series. So all low frequencies will be passed by the inductor, but they will be blocked here. And little high frequencies, suppose. So the only common region will be allowed by both of them. So all low frequencies will be allowed by inductor, but they will be blocked by capacitor. Further, all high frequencies will be blocked by inductor itself. All high frequencies will be stopped here itself, and all low frequencies will be stopped here. So overall, only the common region will be passed through. So the common region is this. As a function of frequency, the output current is like this. I mean, if you multiply these two, some 0.1 multiplied by 1, you will get 0.1, and near to 1 multiplied, you get near to 1. And further, this gets reduced. So this is 1, this may be 0.1 or 0.2, so we will get a reduction. Okay, so this is called a band pass filter. Band pass filter. This is low pass filter, and this is high pass filter. And if I connect both of them in parallel, what will happen? So all low frequencies will pass through this, and and all high frequencies will pass through this. So only those intermediate frequencies which are moderately low and moderately high will be blocked. So this is band stop filter. Then we have to identify the cutoff frequency or the resonance frequency. This particular frequency is called resonance frequency, and this is the cutoff frequency. Resonance frequency and cutoff frequency. Okay, so here we have to look for the half power point. So general if a number is less than half, we'll round it off to 0. If it is more than half, we'll round it off to 1. Okay, nandi? So alage power vishayamlo vachesariki, if the power is less than half, we consider it as 0, and if it is more than half, we consider it as 1. So if power ki graph gisamu and current ki graph gisamu, how will be the power then? Power kuda ilage vastundi kada. For low pass filter, frequency of power will be like this. Endukante power is I square R. I value manaku telusu, dini square chestam. So power versus frequency also will be like that. So ఇప్పుడు ఇందులో what all the frequencies are passed through అనే క్వశ్చన్ కి ఆన్సర్ ఏమొస్తుంది? ఏమేం పాస్ అయినాయి, ఏమేమి బ్లాక్ అయినాయి. Where should we choose the cutoff point? Cutoff point ఎక్కడ పెట్టాలంటే, సో ఈ పవర్ లో హాఫ్ కన్నా అబౌవ్ ఉన్నదంతా పాస్ అని చెప్తాము, హాఫ్ కన్నా బిలో ఉన్నదంతా బ్లాక్. So this is P by 2. Right? The same effect will reflect here as I by root 2. I square antam kabatti the same half power point in current graph will reflect it I by root 2. When you consider power half, the resultant effect in current graph is at I by root 2 because P is proportional to I square. Right? So this point is called half power point. Half power point. Is that clear? So the frequency corresponding to half power point is called cutoff frequency. So below that frequencies are passed, above that frequencies are stopped. The frequency corresponding to half power point is the cutoff frequency. Right. So if I represent these things on an imaginary graph, etla represent cheyalante, resistance is a real number, and j omega L is an imaginary number. J omega L is an imaginary number, resistance is real. So I'll represent like this. So the name of this is called phasor diagram. A graph of phases. There is a 90 degrees phase difference between current through resistance and current through inductor. Current through resistance ki, current through inductor ki 90 degrees phase difference undi. So the corresponding phasor diagram for capacitor CR circuit is like this. This is R. This is minus J by omega C or 1 by J omega C. 1 by J omega C నేను ఎట్లా రాస్తున్నాను minus J by omega C అని రాస్తాను. So it will come along the negative axis. 1 by I అంటే minus I కదా. So the phase angle ఎట్లా వస్తుంది slope of the resultant. ఇప్పుడు resultant impedance ఏమవుతుంది Z comes along this one. Impedance is the resultant of this one. This is Z. Here Z is equal to R minus J by omega C. The resultant impedance means sum of the resistance and reactance. For RL circuit it is R plus J omega L. It is R minus J by omega C. For this circuit it is, we'll see that later. First of all we try to understand these two, then we'll see that. Okay, so for inductor circuit total impedance is R plus J omega L, and for capacitor RC circuit it is R minus J by omega C. So now the phase angle ఎట్లా చెప్తారండి అంటే ఎంత షిఫ్ట్ అయింది అని అంటే when you have pure capacitor there will be a minus 90 degree shift, complete minus 90 వస్తుంది. If you have pure inductor you will have plus 90 shift. If you have combination of both L and R or C and R, there will be a difference. It will be between 0 and 90 or 0 and minus 90. A number ఎట్లా వస్తుందంటే it is the slope of this resultant. ఆ resultant line యొక్క slope ని మనము phase angle అని తీసుకుంటాం. If that slope is 90 degrees, otherwise any number, it is that number. Slope ఎట్లా వస్తుందంటే it is tan theta, or I call it as tan phi. It is dy by dx. The length along y axis and length along x axis. It is r by minus j by omega c. Here it is tan phi is equal to r by j omega L. So we're able to calculate the resultant magnitude. Magnitude ఏమవుతుందండి ఇప్పుడు magnitude of impedance modulus Z is R square plus omega L square. Here it is R square plus 1 by omega C square. Magnitude A plus IB multiplied by A minus IB. Complex number ki complex conjugate తీసుకొని multiply చేస్తాం. We'll get A square plus B square. So for both you'll get positive R square plus 1 by omega C square, R square plus omega L square. Okay, so that is about R, L and CR circuits, CR and LR circuits. Okay. Now what about the cutoff frequency? So here in a LR circuit, the cutoff frequency is given by, it is a condition where tan phi is equal to 45 degrees. Fc is equal to the frequency at tan phi at phi is equal to 45 degrees. Cutoff frequency is the frequency where those two are equal. The resistance and reactance become equal. 45 degrees అంటే ఏంటంటే రెండు ఈక్వల్ అవ్వాలి. tan 45 is 1. ఆ రేషియో 1 అయ్యేలాంటి పరిస్థితి. అంటే ఏంటి? R by j omega L is 1. Otherwise magnitude wise చూసుకున్నట్లయితే R by omega L is equal to 1 అవ్వాలి. సో ఇందులోంచి కట్ ఆఫ్ ఫ్రీక్వెన్సీ ఎట్లా వస్తుంది? I call it as omega C. Yeah, R by 2 pi FCL is 1. Our cutoff frequency FC is R by 2 pi L. What about capacitor? Work it out. R by 1 by omega C is 1. So omega CR is 1. 2 pi FCR is 1.
1 by 2 pi.
FC is 1 by 2 pi CR. Okay, so we have 4 different circuits for 4 different applications. So one is low pass filter, another high pass, band pass and band stop. So the circuit here is low pass, yeah, low pass inductor RC circuit. Now I can use a single capacitor to develop a low pass filter also. So ఇక్కడ ఏం చేస్తుందండి, ఇండక్టర్ allows only low frequencies. DC అయితే డైరెక్ట్ గా allow చేసేస్తుంది. All low frequencies are allowed freely and high frequencies are blocked. So alternatively, what I do here is I use a capacitor to send all high frequencies to ground. So all low frequencies will be blocked here, they will be sent to the resistor, and all high frequencies will be passed through the capacitor to ground. So I can use a capacitor to develop a low pass filter as well. Similarly, I can use an inductor to develop high pass filter. All low frequencies will be grounded, only high frequencies will reach the resistor. Same way, band pass filter can be generated by using a parallel combination of L and C. This parallel combination blocks a particular band of frequencies, remaining all other frequencies will be grounded. Whatever blocked will reach the resistor. Full page wire. The same way, this is a band stop filter. So another possibility, if I use both L and C, I want to use all L, C and R to develop a low pass filter. Etla cheyalante, it will come as combination of both. Some of the low frequencies are allowed by the inductor. If at all any high frequency still remains, it will be grounded by capacitor. Here, high pass filter. here. These are the simple versions. Another most widely used versions are pi filter and T filter. Pi filter contains two grounded versions and one allowing version. T filter contains two allowing versions and one grounded version. Okay, so if I want to develop a pi filter for low pass, how will it be? It's in the shape of pi. So it contains two grounded components and one allowing component. Low pass pi filter. Same high pass pi filter is similarly band pass and band stop. Okay. So this is pi filter for band pass. Last option, T filter, low pass, high pass and band pass. So the equation for low pass filter ఏమొస్తుందండి? Cut off frequency for low pass filter is R by 2 pi L, and cut off frequency for high pass 1 by 2 pi RC. Okay, and if you take any combination, that will be reflected something like R by 2 pi root L1 and L2. If you have a few more components, here it is 1 by 2 pi R square root of C1 and C2. What about combination? We'll see those equations later. Okay, so I'll go into the next topic. So next we'll discuss about LCR circuit. LCR series combination. Okay, so here the phasor diagram will have three components: R minus J by omega C, J plus J omega L. If these two are equal, if omega L is equal to 1 by omega C, then the circuit is pure resistive. So Z contains only R. So ఇక్కడ Z value ఏంటంటే resultant of all the three. So you have to write all the three: R plus J omega L minus J by omega C. If these two are equal, they'll get cancelled. So if these two are equal, they'll get cancelled and only resistance remains. Okay, so if omega L is greater than 1 by omega C, then circuit is inductive. Inductive అంటే ఏంటంటే current lags. And if omega L is less than omega C, current leads. Okay. So output current diagram లో మనకి ఏమేమి వస్తాయంటే, So this is resonance frequency, lower cutoff frequency, upper cutoff frequency. This is, let's say this is I maximum, Im by root 2, half power point. So at this resonance frequency, the circuit is resistive. Here it is inductive. And here it is capacitive. So the resonance frequency is given by the condition omega L is equal to 1 by omega C. This is the resonance condition. అంటే ఏంటంటే రెజొనెన్స్ ఫ్రీక్వెన్సీ ఎట్లా వస్తుంది 2 FCL is equal to 1 by FR అనండి లేదా రెజొనెన్స్. So FR square is 1 by 4 pi square LC FR 1 by 2 pi root of, that is the resonance frequency. And for inductive, what shall we do? Sir, reverse అవుతాను కన్ఫర్మ్ చేసుకోవాలి. This one is inductive because this falling is due to inductive effect, right? Inductor curve లో మనకి ఇట్లా వస్తుంది, కెపాసిటర్ కర్వ్ లో రైజ్ అయ్యే పోర్షన్ వస్తుంది. This portion is controlled by capacitor and this portion is controlled by inductor. Maybe at exchange also. అర్థమవుతుందండి. సో లోవర్ కట్ ఆఫ్ ఫ్రీక్వెన్సీ ఇస్ కంట్రోల్డ్ బై కెపాసిటర్ అండ్ అప్పర్ కట్ ఆఫ్ ఫ్రీక్వెన్సీ ఇస్ కంట్రోల్డ్ బై ఇండక్టర్. కొంచెం ఎక్స్చేంజ్ చేయాలి. వాల్యూస్ ఆర్ ద సేమ్. And finally, we have to calculate the bandwidth or quality factor. I am defining bandwidth I call it as delta F, and resonance frequency F naught or F or whatever it is. Then I define quality factor as F naught by delta F. Capacity. This is inductive. Now, quality factor. Because circuit changes in band pass filter. What does it do? What is the use of it? It allows a particular band of frequencies. Then మనం ఎక్కడ వాడతాం? It is used in all communication systems. That includes our TV remotes, cell phones, everything. Suppose మీరు ఏదో ఒక ఈటీవీనో జీటీవీనో సెలెక్ట్ చేయాలి, ఏదో నెంబర్ ప్రెస్ చేస్తున్నారు, 236 అనో 521 ఏదో నెంబర్స్ ప్రెస్ చేస్తున్నారు. So our channel ki corresponding band of frequencies will be passed to the display. So remote lo jarigedi entante, the LNC values will be selected, will get selected, so that that particular band of frequencies will be passed to the display. So మనం ఒక్కొక్క నెంబర్ మారుస్తున్నాము, ఒక్కొక్క ఛానల్ మారుస్తున్నాము అంటే we are tuning it to a different band of frequencies. Okay, even our cell phones, when you dial a number, you are tuning to a particular band. Our receiver end lo kuda same frequency tune ayi unte, I mean whatever number you are dialing, whatever your words will be transmitted or received only by that particular cell phone. అర్థమవుతుందండి? మీరు డయల్ చేసే నెంబర్ ఏంటి అంటే ఇట్ ఈస్ ద రెజొనెన్స్ ఫ్రీక్వెన్సీ ఆఫ్ దట్ పర్టిక్యులర్ పర్సన్స్ రిసీవర్. సో గాలిలో ఈ టవర్ చుట్టూ ఇంతమంది 100 మంది 1000 మంది మాట్లాడుతున్నా సరే మన ఫోన్లోకి ఆ ఒక్క మాటలే వినపడటానికి కారణం ఏంటి? ఇట్ ఈస్ ద రెజొనెన్స్ ఫ్రీక్వెన్సీ. ఓన్లీ దోస్ బ్యాండ్ ఆఫ్ ఫ్రీక్వెన్సీస్ విల్ బి పాస్ టు అవర్ హ్యాండ్సెట్స్. Okay. Right. So now how to define the quality factor? Ante nenu oka particular channel ni tune cheddam anukuntunnanu. How best I can tune to that particular channel is defined by quality factor. So nenu లెట్స్ సే నేను జీటీవీలో ట్యూన్ చేద్దాం అనుకున్నాను. సగం జీటీవీ ఇమేజ్ వస్తుంది, మిగతా సగం మా టీవీలోంచి ఇమేజెస్ వర్డ్స్ జాయిన్ అయిపోతున్నాయి సౌండ్. ఏమవుతుందండి? సో ద క్వాలిటీ ఫ్యాక్టర్ ఈస్ మోర్ ఇఫ్ the band of frequencies I'm selecting. Actually, I want to select the resonance frequency. I want to tune to a particular frequency, and these are actually unwanted frequencies, the band of frequencies. So, ఈ band ఎంత తక్కువ ఉంటే అంత high quality అని నేను define చేయొచ్చు. So, quality factor is inversely proportional to delta F. And quality factor is proportional to the resonance frequency. దాని మీద ఎందుకు డిపెండ్ అవుతుంది అనేది చూడాలి. Let's say the circuit allows, let's say if I want to select 100 hedges. So my aim is to select 100 edges and the bandwidth is 10. The unwanted frequencies or whatever frequencies entering into the circuit are from 95 to 105. Okay. So what is the error? There is a 10% error. Right? I wanted to select 100 hedges and extra frequencies entering into the circuit are in a band of 10 hedges. And now I want to select 1 lakh hedges. And if the bandwidth is the same, and ఏంటంటే which one is a better selector? Here out of 1 lakh the error is only 10. Here out of 100 the error is 10. So if the resonance frequency is very large, a moderate amount of bandwidth is considerable. అంతే కదండి. నేను 100 హెడ్ సెలెక్ట్ చేసినప్పుడు 9500 బ్యాండ్విడ్త్ 10 అనేది వెరీ లార్జ్ ఎర్రర్ లాగా కనిపిస్తుంది. Whereas if I select 1 lakh, the same bandwidth of 10 hedges seems to be negligible. So the quality factor is directly proportional to the frequency you are selecting. So in total, quality factor is F naught by delta. Okay. So actually these band of frequencies carry the actual information. So those details we'll see later whenever that comes.